Welcome to Ask and Learn.
All right, so guys, we're doing problem 68 of chapter 18 in Chemistry Central Science. Today wants to explain, using Le Chatelier's principle, why the equilibrium constant for the formation of NO from N2 and O2 increases with increasing temperature, whereas the equilibrium constant for formation of N2 from NO and O2 decreases with increasing temperature. So let's review what Le Chatelier's principle is. So Le Chatelier, so normally we have a kind of reaction. A plus B is going to equal product C. However, not all of our reactants are going to be used, and we're never going to have 100% yield of product. So thus, eventually, we're going to reach a state of equilibrium, where we're going to have a certain percentage of reactants, certain percentage of products. And we can quantify this using our equilibrium reaction, equilibrium constant. It's going to be the concentration of C over the concentration of A times the concentration of B. So when we do this in terms of concentration, if the concentration of C increases, that's going to lead to the shift the equilibrium to the left to create more of A and B. Conversely, if we add more of A and B, that's going to shift the equilibrium to the right, and create more of product C. If we disrupt the equilibrium, our reaction has to our system has to equilibrate so that we have a specific ratio of reactants of products to produce our specific equilibrium constant. Now, this in terms of concentration. We also can put this in terms of temperature. So we have two kinds of reactions. Let me just erase all this. We have two kinds of reactions. We have delta H is greater than 0, which are going to be endothermic. And we have delta H is less than 0. These are going to be exothermic. So endothermic reactions, the energy of your system will increase from reactants to products, while in exothermic reactions, your energy will decrease from reactants to products. So basically, in endothermic reactions, your system gains energy. In exothermic reactions, you release energy. So this is what it would look like. A plus heat, which I'll just denote as Q, yields C. That's going to be an endothermic reaction. An exothermic reaction is going to be B is going to decompose and produce heat and produce product D plus heat. So endothermic, you're adding heat. Your heat is a reactant, versus exothermic, where your heat is a product. Now, remember what heat is. Like, heat is going to denote the transfer of energy, and temperature is the average kinetic energy of our system. So we're going. So we can you can guess how temperature is going to affect the equilibrium in terms of Le Chatelier's principle. So for endothermic reactions, you're increasing the temperature, so you're adding heat to your system. So that's going to cause your reaction to shift to the right. Right. Now, S. Now, for B, since heat is your product, and if you're increasing temperature, adding heat, it's increasing Q is going to shift the equilibrium to the left. It's the basic principle of Le Chatelier's principle. Oh, is you're increasing your temperature, that's going to affect your equilibrium. But usually we do. But usually when we talk about equilibrium constant, we talk about it in terms of concentration. So like the concentration of your products will increase, your concentration, if we increase the concentration of your products, your concentration of some of your products will be converted to reactants to make sure your equilibrium constant stays constant. So this means that, if your equilibrium is shifting with temperature, that means that KEQ, that your equilibrium constant, is actually a function of temperature. So it depends on the temperature that you're using. Okay. It's a function of temperature. And it's going to be so what temperature you're using, that's going to affect which way your equilibrium is going to shift, even though the concentration of your reactants and products may be the same in a relative sense. Even if you're not changing the overall concentration of your reactants and products, and you just have what you have in your system, which will not affect your equilibrium. The temperature affects your equilibrium because it will shift your reaction to the right, or it will shift your reaction to the left. Sorry, F. If you're adding heat. Inversely, for endothermic reactions, if you decrease this heat, that's going to shift the equilibrium to the left. And for exothermic reactions, if you decrease heat, you're going to shift the equilibrium to the right, because you're going to be you want to produce more heat to equilibrate your system. Conversely, in endothermic reactions, if you decrease temperature, you can't produce as much product. So now let's look at our two reactions. So we have the formation of NO from, in fact, let me get a different color. You have the production of NO from N2 plus O2 yields 2NO. And we have N2O, we have O2 plus NO yields NO2. So in the first equation, as KEQ increases, temperature increases. Conversely, for the formation of NO2, KEQ decreases, ST increases. So based on this, we can determine whether these reactions are exothermic or endothermic. So remember, for endothermic reactions, if you're increasing your heat, you're increasing your Q, it's going to shift your equilibrium to the right, and your equilibrium constant will be greater. So this is an endothermic reaction. And now this one, and KEQ is decreasing, while temperature is increasing. So that means your equilibrium is being shifted to the left, is being shifted towards your reactants. That's a sign of an exothermic reaction. If you increase Q, your reaction will shift to the left. So this is how Le Chatelier's principle works with temperature. It depends on the enthalpy of your reaction, because which way your reaction is going to move, that's going to depend on the energy being dependent on the energy that's being absorbed by your system or that's being produced by your system. And your temperature has an effect on it. So this is why some reactions will work better at warmer temperatures, some will work better at colder temperatures. Like there's some crystallization reactions that you perform inside of an ice bath. You perform in an ice bath because it makes your crystals easier to form. Conversely, there's sometimes you want to do things at very high temperature because it's going to make your products easier to form. And you just have so you have to understand the way that temperature and enthalpy play a role in how your equilibrium is shifted.